Welcome to our first lab on EIGRP Multi-Technology. I'm in GNS3 here, and I'm just going to show you why this is my preferred way to do the routing labs when we have no layer 2 switching going on. So I'm just dragging over my routers. This isn't a tutorial, by the way, for GNS3. It's just showing you me using GNS3 that's already been set up. It's my virtual rack, by the way. Now, you can add modules down here. I'm going to do a correction in a moment because I want to match the interface names. How you apply the modules here affects your choices. So if you go up in a minute to the there's a little icon where you can connect the devices together. You'll see that I need to just do one more change. Now, if you're pretty smart, you can actually renumber in the topology the interface names. I suggest you don't do that yet. You just get a bit of time just following along with what I'm doing, especially if you're a bit rusty, and then what you can do is create your own topologies. I'm adding WIC2Ts at the moment in the WIC slots, but then I'm going to go up and add a serial card under the modules. So under the adapters at the top, sorry. Cisco naming I can't even pronounce it, nomenclature changes how the interfaces are numbered and named. So this will work fine, serial 0 to 0. When I try and connect these devices, I'm looking for serial, if I just check the topology, sorry, serial 0/1, 1/1, 1/2, and it just makes it too complicated if we have to start swapping them for these labs. So I haven't turned on the devices yet, so I can just add and remove cables. The other two buttons at the top are to add the interface names and the device names, and it automatically names the devices in order that you drag them onto the canvas. So I'm going to go up here and we'll go to the slots. So just quickly doing a Google search in another window to check the interface numbering and names. If you want to configure the devices, it's just a right click and then you go to configure slots, and I'm going to go to NM4T for slot 1. That's any device that needs interface serial 1 and then whatever 1/1. And you can see I've got an extra 4 ports there, serial 10, 11, 12, 13. So then this allows me to connect all my devices up just as we have in the topology. You feel free later on when you come back to make obviously your own labs up, change the connections, change from serial to Ethernet, because all of this has a bearing when we're doing different routing protocols and redistribution. So hopefully you've got the topology somewhere in front of you, and you can see that I'm matching it per interface and per device. I'll just click on the device names so we know where we are, 1, 2, 3 and 4. You can see when I put the fast Ethernet IP addresses on, our Ethernet devices aren't actually connected, our interfaces aren't connected. They are in later labs. So it tells you in the book, there's a little paragraph when you start about cabling, but also you need to just issue a couple of commands. I'm just pressing the start button there to start the devices. You need to add the keep alive command on your fast Ethernet. What that does is it stops the interface from going down when it doesn't see Ethernet keep alives, and will issue the loopback command also. You will also need to, because there's no keep alives, you'll need to no shut your fast Ethernet interfaces. So I'm just ordering my windows in a nice orderly way so I can quickly click between devices. When you're doing this, you will see the device names underneath the windows at the bottom. I've just taken them out of the screenshot. The next labs will be a bit shorter because I'm not going to have to show you how to do all of this again from scratch. So look at the IP addresses 150, 160, 170, and then we've got some 151, 2 and 3 on routers 1, 2 and 3. We'll have on-demand routing on the bottom so we can just demonstrate that. Check the syllabus because it was in, but sometimes they take it out. Sometimes they take things out of the syllabus, but then they say that they're at liberty to still ask you questions about stuff not in the syllabus. So I'm doing my best here to prepare you for all eventualities. There's the note there, basically telling you to do no keep alives and no shutdown and loopback command on your fast Ethernet. We'll configure the host names and IP addresses. Now actually on GNS3 you don't need a host name because it's auto allocated when you drag them onto the canvas. The other thing is I'm going to add a DCE clock rate to one of the ends. However, these are auto added for you in addition, so you don't need to worry about that. If you're using live equipment, then obviously do the show controllers command and then add a clock rate to whichever device, whichever end is the DCE. So I'm on the fast Ethernet now of router 1. I always like to have the topology diagram in front of me, if possible printed off because I write notes all over mine and I draw the networks and any other configurations, prefix lists, stubs, or just watch first time through and then second time through follow along with me. So I think possibly just for this lab I'm doing the IP addressing and showing you the options, and then after that I'm sure you're more than capable of doing this. issue the show controller command, and it's shows you that it's got a clock rate, and they all show as DCE. This is just one of the foibles of GNS3. Just saves you another little headache step, but the only thing is you just need to make a mental note that if you do configure live equipment or packet tracer, then you will need a DCE command. So you show IP interface brief will show you IP addresses. I was looking for a command that would show the secondary addresses, and I had to do some check-in, but unfortunately you have to do the show run command or show run interface fast Ethernet 0/0, or whichever interface. So here's the show run interface fast Ethernet 0/0, and you can see our two secondary and our primary IP addresses. I just wanted you to see how to find those addresses, and just to ensure they've been configured correctly. Just going to do a few ping tests. These are all going to be point-to-point pings because we don't have any routing enabled yet. Okay, task 2, we're just going to configure EIGRP as per the requirements. Ensure that no EIG packets are sent and received on any interfaces which have EIGRP enabled but no neighbors. So this hopefully will make a command come to mind. The command will be passive interface under the config router prompt. I've said a few times that the requirements don't actually tell you the commands. That would defeat the object, I guess. So I'll add our EIGRP. We're going to use wildcard masks. So we can specify which particular networks and subnets we want to advertise, so not the entire network. We'll issue the show IP EIGRP neighbors command, and you should see your respective neighbors on each device. Obviously they'll have a different EIGRP router ID. See the 10.10, the 10.1, you'll see the 9 and the 5 address on router 3. If you're not seeing it, then obviously check your interfaces and double check which networks you've configured. It's so easy just to hit the wrong key, and obviously things aren't going to work for you as expected. The other thing that we need to note is the show IP protocols command is the one that will tell us if we have any passive interfaces configured. Really important you remember that command and the fact that it will display all these things you can see, your networks, but also which interfaces are passive. If you're doing a show run, it's a bit amateurish, and it kind of gives away you don't know what you're doing. Here's your metrics. You probably know from your theory that K1 and K3 are turned on for EIGRP. You can obviously change that, but you normally, on a live network, you would certainly need to speak to Cisco TAC before doing so. Configure on-demand routing between 3 and 4. 3 receives the 150.440, the 160.170 via ODR. For on-demand routing to work, you need to have a Cisco Discovery Protocol working. If for any reason you've disabled it, or later if Cisco change it in their iOS so it's turned off by default, then you would need to enable it globally or per interface. I mean, I always recommend per interface if you've read any of my books or watched my videos, if it's disabled, but doesn't matter for this lab as long as it's on. And then we'll go router on-demand routing. That's pretty easy. I just noticed my interface was down on R4. I forgot to issue the no keeper lives and no shut. I did tell you to do that at the start, so and I did say I make mistakes as well. Show IP route ODR. Just need to give it a moment. Just remember, if this uses CDP, it follows the CDP timers. Now I need to check by issuing the show CDP command, but there you go. So the routes have all been forwarded now, 160, 170, 150. But it has to follow the timers, as I said. Show IP route. I need to issue the show IP route on router 4. You can see the ODR routes here. Now on router 4 you'll just have a summary, so all the zeros. And if you look at the key at the top there, it says lowercase o stands for ODR. So that fulfills that requirement. Next we have to configure the network so the other routers can reach the 150, 60, 70 on R4. We're going to be assigning route tags of 150, 160, 170 and then making sure the devices can ping each other. Now there's a few ways that this task can be completed. So sometimes there's no right or wrong answer, and sometimes they will say configure this using such a command, or they say you are not allowed to use such a command, or they might say you are only allowed to do configurations on router 3 or 4 or whatever. So given that information, that then reveals to you what your options are, and sometimes they're trying to close you down to just one option. What we're going to do is configure some prefix lists, route maps, and then we'll do some redistribution. So this is pretty advanced stuff, and I obviously accept that it's a big leap from the CCNA to get up to CCNP, but it really is. It's like leaving college and then going off to do a degree. Massive leap in the level. Follow along with me, and then you should have the same outputs if you follow along with me, and then go back to your theory books and then do some more labs. There's no secrets to the process. There was a typo there, sorry. It should say net-170. So I'll add the prefix lists, and then I refer to these in the route maps when I'm matching the IP address. So there's 3 levels to these. It's pretty tough. So obviously the set tag sets the tag as per the requirement. Obviously I didn't pick up the typo when I recorded this. I'm only picking it up when I do the commentary. So that was my mistake. So the net 170 obviously won't match the 179 I had above there. So when you come to configure it, you'll hopefully not do the same thing I did. Anyway, we're going to redistribute ODR now. We're going to reference the route map ODR to EIGRP. We have to redistribute the connected networks. And then for EIGRP, we have to fill in a metric for each of the 5 fields, each of the 5 K values. Follow along with mine for now. And then the command is show IP EIGRP topology. You need to find the pipe command. Mine's next to the / or the / sorry, shift, and then it's just above the /. But I've got an Australian keyboard, so yours might be different. So these are pipes, and these let you drill down into further detail, and it restricts how much output is actually shown when you do these show commands. So I finally found mine, just a straight down arrow called a pipe. Include, I'm looking for a tag, and then pipe, and then redistributed. And you have to spell all this correctly. It won't pick up if you type it incorrectly. Alright, so the 170 worked. I'd have to go back and check as to why it worked, because I called the wrong prefix list, so I'm not sure why that worked. Not that I'm complaining. There should be a ODR listed as unknown somewhere just down here. That's to be expected. And there we go. The external protocol is unknown. External metric is 1. And then next we just need to do some pings. Ping 10.0014 with we'll specify the source address of 150.111. Our final ping test. This is before we're completing task 5. I'm just going to look at the external route entries. You can see the 170, 160, 150. Now we configure the network so that R1 prefers the path via R2 to reach the 153, 154, and all of the routes should follow the best path. So we should see a change in the path for 150.330 and 154.40. At the moment you can see 10.0.0.6. So look at that output, then grab your topology for this network, and then we'll do this configuration here, and you should see the path change for the 153 network, 154 to 10.0.0.2. So this will change, we'll use an offset list, and this will change the metric so that the preferred value is as per the requirement number 5. Alright, when I do the show IP route command again, you'll see the new routes. Just here, 10.2.